Hello everyone. This example is called Heron problem. So we want to find out if we are given 2 points like A and B on the same side of a line called L, and we want to find out a point D, the green one on this graph, in a way that the sum of the distances from A to D and also D to B are minimum. Okay, the summation of D1 plus D2 are minimum. What are the given parameters of the problem? The parameters, the input data of the problem are L, H1 and H2. Okay, so both of these two quantities are known, and the decision variables are X, D1 and D2. Actually, if we know the X, we know everything else. Okay, so the only decision variable is X in this problem. Okay, so let's write down the mathematical formulation. Minimization of D1 plus D2 subject to some constraints. So on the first triangle, you can see here there is a relation between X and H1 and D1. X squared plus H1 squared is D1 squared. And also on this triangle, L minus X, which is here, square plus H2 square is equal to D2 square. Okay, so let's write it down in Python. First of all, like the other examples, we have to import the Pyomo environment and then import NumPy if we need it. And also we have to define a model. Here it's a concrete model, and also the parameters of the model. There are 3 parameters in this specific example: L, H1 and H2, and we have to initialize them. We have to tell Python that what are the values for them, and also 3 variables: D1, D2 and X. Also D1 and D2 can be found using X, but since we don't know their quantity and the value, we have to define them as variable. And also we know that the range that D1 and D2 can change is between 0 and L. Okay, and we can initialize them as well. And also X variable is between 0 and L as well, and we initialize them as all of them equal to 0. You can choose any other number. And also we have 2 constraints, C1 and C2. The constraint C1 is telling us expression equal model D1 square is equal to model H1 square plus model X square. And the second constraint is telling us D2 square is equal to model H2 square plus model L minus X square. Okay, and the objective function is the summation of D1 plus D2, and the sense of optimization is minimize. Like every other optimization example, we have to run all the tabs one by one and then choose the solver, which is obviously the problem is a nonlinear programming because of the constraints. Okay, the constraints, you can see the nonlinearity terms. Okay, I run this one, so I have specified so far the solver for solving the problem, and the results will contain the decision variables all and also the objective function. So if I print the results, you can see here that the D1 is 3.89, D2 is 7.77 and X is 3.33 and F1 is 11.66. okay, and this is a non-linear kind of programming. Thank you very much.